Good morning, everyone. Today I'm going to give a presentation on the topic on camera pose estimation for a 3D scene reconstruction. What is scene reconstruction? Imagine a world in which this is a global coordinate frame and a camera is moved along a complex trajectory as shown in the picture. And at various positions along the trajectory, images are taken of the environment. The goal of scene reconstruction is to use this collection of images to construct a single spatially and temporally coherent 3D model of the environment with respect to scale. So this is done by estimating the poses of the camera at various points along the trajectory and the relative poses between them. So it boils down to estimating this set of poses. For estimating relative poses between images or cameras, we can use local camera pose estimation techniques. We are using RGB as well as the depth values for processing, and we can integrate them into a format called point clouds. However, we are not converting the entire pixels into point cloud since it will be computationally expensive. So we perform shift detection on the images to detect features, and we map similar features. And then we construct an error function, and then we minimize the error function to find the best transformation matrix. This minimization is done using SVD minimization technique. However, when we are matching features, in addition to true positives, there can be false positives. The presence of false positives deeply affect this optimization technique and degrades its quality. So we needed a technique to segregate such outliers from the set of matches. So we have used Ransack for this. Ransack basically function as a voting algorithm. It creates a set of hypotheses, in this case, the related transformation matrix, and computes the number of inliers for each of the hypothesis and the errors using this function. And the one having the minimum error is considered the best model. When we are using Ransack, a number of parameters comes into picture, and we have done a parametric study to find its best values. Figure 6 shows the variation of performing local camera pose estimation with and without Ransack. And as we can see, when Ransack is used, the errors decrease greatly. Figure 5 shows the mesh created after performing local camera pose estimation. However, using local camera pose estimation by itself is not enough since it does not solve problems like loop closures. We needed to perform global camera pose estimation. The traditional way of doing a global camera pose estimation is using gradient-based techniques. However, in this paper, we are exploring meta-heuristic techniques such as GA. We describe the poses using SE3 representation instead of transformation matrices, since it will be difficult to enforce orthogonality condition with transformation matrices in each iteration during GA. The problem will here will boil down to estimating this 6n dimensional vector called psi. This is the fitness function which we are using, and it is approximated as shown here to improve the convergence. The individual having the minimum fitness is the solution which we are seeking. These are the other parameters of the GA which we have used. Figure 8 shows the variation in fitness and average fitness and minimum fitness of the population with each generation. And as we can see, it decreases with each generation. The individual having the minimum fitness at the end of this last generation is plotted here as shown. Figure 10 shows the variation of minimum fitness of an individual with population size. Figure 11 shows the variation of the minimum fitness of an individual with the maximum number of generations. And figure 12 shows the variation with crossover probability. As we can see, higher values of these parameters are better. Figure 13 shows the variation with a mutation probability, and it does not seem to follow any visible trends. So, in conclusion, local pose estimation was performed using RAMSAC and feature detection algorithms, and global camera pose estimation was performed using GA. And it was shown that meta-heuristic algorithms can also be used for performing pose estimation, and the effect of different parameters was also studied. So we can combine these together to form a scene reconstruction pipeline as shown here. So in future, we plan to dive further into the details of this GA approach, and to get more insights and to compare it with other benchmark techniques. Also, we plan to integrate the GA-based technique with a minimal deep neural network to see further outcomes. That's all. Thank you.